Alright, so you should attempt to solve these coding questions yourself. Try to spend a good, half hour, 45 minutes. And after doing that, please watch this video where I'll explain how to do these coding problems. Alright, so let's try the first one. Ask a user to enter a number from 2 to 12. Using random functions, simulate rolling a pair of dice until the selected number came up. Report how long it took. Alright, first step is we need to use the random library. So import random. We only need the randint, so why don't we do it this way? From random import randint. You could also call it like we did in the lecture, random.randint. Alright, so let's see. We want to ask the user to enter a number from 2 to 12. So x equals int input, enter a integer from 2 to 12. Alright, so we got our integer now. Now we're going to roll the dice. So to roll the dice, we need two random numbers. So A, and we need to do this in a loop, right? We got to roll the dice until we get the selected number. All right, so let's start an infinite loop while true. Okay, and when we get the when we roll the dice and get the number that we picked, we'll just break out of this infinite loop. All right, so let's roll the dice. So we're going to say n equals randint. So when you roll the dice, you roll two dice. So we don't just want a random number from 2 to 12. We need to add two random numbers from 1 to 6. If you don't understand why, you need to take probability and statistics. It's a different random variable. So you have to use two discrete uniform distributions from 1 to 6 and add them together, and that's what you do when you roll the dice. Each dice is a uniform random distribution. Alright, so while true, we're going to roll the dice. Okay, then let's check and see. Did we get the original guess? So x is our original guess. So let's see if n is equal to x. So if n is equal to x. Alright, so if we do achieve this, we want to break out of this infinite loop. Okay. Now, we want to count how many times we actually had to roll the dice. So each time we do line 5, where we're rolling the dice. So let's set up a counter. So C equals 0, and we'll say C plus equals 1. So each time we roll the dice, we will add 1 to C. Okay, so we add 1 to C, we counted each roll, and if we get back the original number that we inputted, if n happens to equal that by random chance, then we will break out. And then the final thing to do is to leave the loop. So when we break out, we're out. And let's report on C. So print, it took this many times to roll the number %s. And why don't we just fill in this as a formatted string. So x is, it took C. C represents the number of rolls, and x was our original roll. And in fact, if you want to make it a little bit more interactive, we could, each time we roll, we could say print we rolled a comma n. So all right, so let's test it out, make sure I didn't make any syntax errors. All right, enter an integer from 2 to 12. Let's try 7. All right, look what we rolled. It took 27 to roll the number 7. If we want to count this, we can say roll number C. But we want to update C, so let's put this here. Let's update C first, and then we'll report on how many times we rolled. All right, so let's see, we update C. We need a comma here, then we need another quote. All right, let's try it again. 7. Well, this time it only took 3 rolls. 1, 2, 3. Let's try a hard one like 12. Look at that. It took 64 rolls to get a 12. Let's try a 2. All right, something went wrong. All right, to get a 2, took 45 rolls. All right, so I think we got that figured out. If you have any questions about this one, come to office hours. It's definitely a little bit complicated, more so than some of the other problems we've done. You don't need to use a infinite loop. You could also say, you know, while n is not equal to x. Like if you wanted to do it that way, you could say it like this. You could say n equals none. And then you could say while x is not equal to n. And when n is equal to x, then it will, when n is equal to x, it will stop going into the loop. So let's try it out. Okay, I've got the colon here. Let's try 7. Yeah, seems to be working. Let's try 12. I'm not sure why it's doing this. I might have to restart the runtime. All right. Sometimes Colab is a little buggy. Alright, I think we're done with this one, which is the preferred way. I think I like this way better. This is more professional, but as a beginner programmer, you're probably better off doing it the first way. None means empty. Like, think of none as like left blank. Like n doesn't have a value yet. Okay. Suppose you owe $50,000 on a car loan. Each month you're charged 1% of the balance at the end of the month. Ask the user to enter their minimum payment. Using a while loop, calculate how many months it takes to pay off the loan. Okay, so let's let our principal equal 50,000, and the interest rate is 0.01, and that's the monthly rate. Okay. We'll ask the user to enter their minimum payment. Okay, so X equals float. It could be a decimal. Input. Enter min payment. Okay, all right, so we got the payment. All right, so now let's go to the first month. So let's let n equal the number of months. So let n equal 1. And all right, so let's do a while loop. So while principal is greater than 0. All right, so let's see. Let's print the month. Month is month. All right, so we'll print the current month. N is going to represent the month. Now, let's should we apply the interest first, or should we make the payment first? I think more accurately would be to apply the interest first, because it's sort of been accruing the entire month. So let's do that. So P equals the old principal plus the interest rate times P. That's the same as P times 1 plus R from math class, right? Okay, all right, so that's our new principal. It went up a bit, but now we're going to say P equals the old value of P minus our minimum payment. Okay, and now let's go to the next month. N plus equals 1. All right, so now let's go to the next month and keep doing this until we're paid off. All right, so let's see. So let's say I'm going to make a minimum payment of $5.50 a month. All right. All right, 241 months. Let me print it sideways just so we could see it better. So I'm going to do it like this. I'm going to print it. I'm just going to print the months like sideways. end equals, so I won't do a new line each time. Also, let's print the principal. Principal P. Alright, so let's see if this looks any better. Let's make $1,000 a month. Alright. Oh, maybe it's better to go down. So let me take this off. Alright, $1,000 a month. And it takes 70 months to pay it off. So after 70 months, the next time it would be paid off. So it's probably going to be one more month. So we might want to put this here. Let's try this out, see what this looks like. Alright, so let's see. So we start out after the first month, we're at $495. Alright, that makes sense because we pay a lot of interest, right? And then eventually, we have a negative balance here. We don't want that to happen. We need a special case, right? Our last payment is going to be less. See if you could fix that. See if you could fix that on your own. Maybe pause the video for a little bit and just give it a try. What you'd have to do is something like this. If the principal is smaller than the minimal payment, then P equals 0. That means we're going to just pay it off. Else, make a regular payment. Alright, let's try this one. See, this is how you code. You experiment. Try different things. Alright, so see? And then our last payment was going to be $655. Alright, 70 months. Now notice, just to show you something, let me stop printing it each month. Let me just take this out of the loop and say print it took n months to pay off. Alright, let's just test it out with 1,000. 70 months to pay off. Now watch what happens. What if you make your payment too small? See, we know that the interest is $500 a month, right? So let's say we pay $502 a month. Look how long it takes. 556 months to pay off. How about $501 a month? This is the minimum payment thing. $625. What if we make the real minimum payment? $501. It took 1,000 months to pay off. Looks like it's almost like 100 years, right? So as you can see, it doesn't really pay to make a little payment like that. That's compound interest. All right, last one. Without using a list, ask the user to enter 3 numbers. Write code to determine the largest of the 3 numbers. Use if, else, or multi-way. All right, so this is a lot easier than the other ones. Not as interesting, but let's give it a try. Ask the user to enter 3 numbers. Okay, a equals int input. All right, so let's get 3 numbers. Okay, let's call this one B and this one C. All right, so let's see. Use if, else, or multi-way. So we want to figure out which one is the biggest, right? So if A is greater than C, if A is it's maybe greater than or equal to C, then we know C is definitely not the biggest, right? It's either A or B. So if A is greater than or equal to B, then the answer is A. Print A. Okay. Now going back to this if this is false, then we know that C is greater than A. So let's check if C is greater than B. So C, you might want to write these down on paper. So if C greater than or equal to B, well, if C is greater than A and C is greater than B, C is the max. So print C. So maybe we should use an elif. All right, well, let's see. So I think we need to continue here. So let's say A is greater than C, but B is greater than A. So by the transitivity, B would be the max, right? Else print B. And if B is greater than C, so, okay, so I'm trying to do this in my head, but it might be easier to write out these cases on paper for sure. So let's see. If C is bigger than B, so all right. So when we're here, when we're right here, we're assuming that C is bigger than A. So if C is also bigger than B, then C is the max. In the other case, B is greater than C, and C is greater than A, so B would be the max again. So print B. All right, so I think I got it. So let's test it out. So this is a little tricky, but there is another way to do it, an easy way. I'll show you next. All right, so let's try 2. Notice you have to input them one at a time. 1. It found 4 is correct. Let's try 1, 2, 3. Got that. Let's try 3, 2, 1. Too fast. I typed it too fast and it messed up the code, see? 3, 2, 1. Now let's put the big number in the middle. 2, 3. I typed it too fast again. Hold on. 2, 3, 1. Alright, I think it works. Alright, there's another way to do this, which is not so preferred, but you could say if A greater than or equal to B greater than or equal to C, print A. Right, let's just test this out. But this is kind of, Python allows you to do this. It's kind of cheating. But then you'd have to do like all 6 cases. But the first method that I just showed you, I think that's ideal. Alright, so let's stop here. And I'll see you all next week. Have a good week, everybody.